everyone, my name is Chang, Chang. Welcome to OneClass livestream. In this livestream of half an hour, we're going to go over some common conceptual math problems, along with some actual math problems where we're going to solve together. So let's get started. So let's get started. So our first question is, what is the value of E? So first, I think we need to know what is E. So the number E is called Euler's number. Why is it called Euler's number? Because this number was originally found or calculated by the mathematician Euler back in the days. So what is the value of, so why would we need this number? Because this number is actually a really common constant that appears in a lot of different areas of mathematics, such as compound interest or in some really common functions. For example, one of the function ln E is, one of the function ln is actually derived from the function logarithm with base e, where this e is, or let's do this, and where this e is actually Euler's number, or Euler's number e. So yeah, it has a lot of applications, and the value of e is actually an irrational number, so it can have many different, or an infinite number of digits of a different number of values, non-repeating. So usually we're just using the first two, so it actually equals to a lot of different numbers, or an irrational number of a lot of different digits. So usually we're just going to use the first two, or we're just going to use 2.72 for the value of e, because with like 3 significant figures, because it's an irrational number. So usually we just use e equals to 2.72, or you might notice the equal sign is like curly here. That means approximately equal to, versus like this means that the number e actually equal to this number. So yeah, that's the number e, or the number Euler's number. And here, yes, it just had some, our sample solution here just has some information on the background of Euler's number, along with a way of deriving Euler's number. So if you're interested, feel free to read it up. So this solution is really great. That's correct. Okay. Now let's move on to our next question. So here we have our second question. The question here just says 11-sided polygon, which I assume they need some information on 11-sided polygon. So a 11-sided polygon, or I guess polygons in general, polygons, which means shapes or geometric shapes with different number of sides. So for example, a pentagon would be a geometric shape with 5 sides. So this 1, 2, 3, 4, 5 would be a pentagon. This is a regular pentagon. The pentagon could also be irregular. So like that. It's also a pentagon, but it's an irregular pentagon, whereas the size is at different length. Similarly, a hexagon would be a shape with 6 sides, a geometric shape with 6 sides. So this would be a regular pentagon or hexagon, and you can also draw an irregular hexagon of shape with different, or of where each side has a different length. The prefix penta or hexa, I think, yes, it is Latin for like 5 or 6. So similarly, for 11-sided polygon would be called I think it's called, yes, it's called a hendecagon, where hendeca is again Latin for 11, but it has some like other names such as it can also be called an endecagon, which is also a name for like 11-sided polygon, or a endecagon. I think the most commonly used name is endecagon for like 11-sided polygon, or maybe hendecagon, depending on where you came from. So yeah, this is the name for 11-sided polygon. And again, I guess we can draw 11-sided polygon together, but it will be kind of hard. So let's do 1, 2, 3, 4, 5, 6, 7, 8, or sorry, 7, 7, 8, 8, 9, 10, 11. Or I guess that's yes, that would be a decagon or an endecagon for like 11-sided polygon. Let's see the sample solution here. Yes, this is a more regular 11-sided polygon than our polygon, but that's basically a 11-sided polygon. They use the name endeca here as well, so yeah, it's the more common name, but it can also be called a hendecagon or an endecagon for 11-sided polygons. So yes, so the solution is correct. Great job, or great job. Here. Perfect. Now let's move on to our third problem. So our third problem is asking us what is the inverse of line. So the inverse of line x, or of line. This is our question. And there are two ways to find this to answer this question. First, we could just tell or we can just answer directly, saying that the inverse function of line x is ex, because by definition, the inverse of the function ln x is the exponential function e to the power of x. So this is our first solution. Or we can do the second solution, where we actually derive the inverse of ln function step by step using the definition of logarithms. So how do we find the inverse function of ln x step by step? So first, so for the function f of x equals to ln x, first we write the function as y equals ln x. Here we don't change anything. Next, we would interchange x and y, so we have the function x equals ln y. Whereas right over here, we can use the definition of logarithms. So we know, first of all, we know that ln y is actually equals to log e to the power of y, where ln y is just a logarithm function with special base e, the Euler's number, like the one like what we talked about in question 1. Then we would try to then we would use the rule of logarithms. So we know that log a to the power of b, or equals, or I guess I should say equals c, is the equivalent of a to the c, or a to the c equals b. So these two are equivalent. So right over here, our a would be e, and our b would be y, and our c would equals to x. So we know this expression right over here, would be the equivalent of the expression of the expression a, which is our e, to the power of c, which is our x, equals to b, which is our expression y. So we have y to the power of ex, and the last step would be just write it, use like f to the power of -1 for y, of x for y, and here we have our inverse function. Our inverse function, e to the power of x. So from here, we know that the inverse function of ln x is equals to the function of, or is the function of e to the power of x, and that's the inverse of the ln function. So here, we found the inverse function of ln x using two methods. One is just by definition, and we know that the inverse function of ln x is e to the power of x. And the second solution is to derive this step by step, where we demonstrated here, and we also found that the inverse function of ln x is e to the power of x. Now let's look at our sample solution. So our sample solution used our second method, where we derived the inverse function of ln x, which is the function of e to the power of x. That's great. So we would say excellent, or excellent. The solution is correct. I think I spelled excellent wrong. Yes, excellent. Good. So that's our third question about the inverse of ln x. Now let's move on to our fourth question. Our fourth question is asking us how would we evaluate log of 100. So this is our fourth question. Oh, whoopsie. Here. So our fourth question is asking us log of 100. From the above, we have our logarithm rule. I'm just going to write it down here again. So our log rule is log a to the power of b equals c. It's the equivalent of of a to the power of c equals to b. So these two expressions are equivalent. In this case, we have the expression log 100. We know that when we just write log 100, it's implicitly assumed that the base a is actually equals to 10. So the question here is actually what is the value of log 10 to the power of, or log 10, 100 with base 10 and b equals to 100. So we know that it is actually asking us the value of the value of c. So we know it is actually asking us our a, which is 10, our a, which is 10, and our b, which is 100, and our c is a question mark. So the question is 10 to the power of what equals to 100, which is actually really simple because we know that 100 is equals to 10 times 10, 10 times 10. So 10 to the power of c equals 10 times 10. So it would be 10 to the power of 2 would equals to 100 because there are two 10s multiplied together right over here. So from here we know the answer is c equals to 2, and we know that log 100 or log 100 is equals to 2. So this is our answer right over here. And let's look at the sample solution. The sample solution used the product property of the logarithms, which also arrived at the same answer where log 100 equals to 2. But I think directly apply the rule of logarithms might be easier because you would know that 10 squared, or 10 to the power of 2, is 100. Cool. So the solution is correct. So we say something like perfect. Perfect. The solution is right. The solution is right. Great job. Yay. Cool. Now let's move on to our fifth problem. Our fifth problem is, how do we simplify ln 5? Simplify ln 5. Actually, ln 5 is the simplest of an expression, and you can't really simplify ln 5 any further. One way to change the expression ln 5 is that we can write ln 5 in exponential form. So this would be, as before, let's rewrite the rules again. So we know that ln 5 is the, or I guess log a to the power of, or sorry, log a, b is the equivalent, or sorry, b equals to c is the equivalent of a to the power of c equals to b. So these two expressions, again, is equivalent. And we know ln 5 is the equivalent of log e, or a log function with a base e. So we know ln 5 is actually equivalent of log e 5, which would be the equivalent of the expression e to the power e, which is our a here, b, which is right over here, and c, which is unknown, so we can represent it by x. Our b over here is 5, so we actually write 5 instead of b. Cool. So these two expressions, this expression is equivalent. So I guess this is another way that we could write this equation, or we can write this expression, but it's not necessarily a simplification, but it is another way that we can write it. So what we can do is that we can actually calculate the value of ln 5. So it actually equals to a number. This, I guess, is the only way that we can simplify ln 5. So let's just calculate that really quickly. Ln 5. I'm also going to charge my laptop because I think the power is out. Now, perfect. Okay, so ln 5, okay, the value of ln 5, according to Google, is actually 1.609437, and we're just going to say that it's approximately 1.61. So this is another way to actually find the value of ln 5. But that's basically all we can do without further information other than ln 5. So yes, to get the value of ln 5, or to evaluate ln 5, we will just use the calculator. Or we can also write ln 5 in the exponential form right over here. So let's look at the sample solution. Yes, they also try to write the expression ln 5 in exponential form, or try to calculate the value of ln 5, which is the same as our value of ln 5. And that's basically all we can do. All right, let's leave a comment saying great job. correct. The solution is right. The solution is right. Yes, perfect. Now let's move on to our sixth problem. And our sixth problem here is asking us what is the arctan function. So it's asking us arctan function. So usually the arctan function is written as is the function y equals to arctan of x. The arctan function is the inverse. So let's write it over here, the inverse of the tangent function. So it's the inverse of tangent function, the inverse of tan x. So that means that if f of x equals to tan x, then f of x is equals to arctan x. Also, arctan is although it's written as arctan x, it can also be written as tan to the power of -1 of x, meaning the inverse function. Cool. Also, note that this does not equals to 1 over 10, or whoopsie, this is not the same as 1 over 10x. 1 over 10x is another function called the reciprocal function of the tan x, of the tangent function, which is cotangent. So yes, it's not the same as 1 over 10x. That's different. So yes, here we have our arctan function. Now let's look at an example of the function arctan x. So example right over here. So let's have a triangle. Let's use the triangle. Let's use a special triangle because that way it's easier. So we have a special triangle. Where the hypotenuse is √2, and both its sides is 1, and the angle here is 45 degrees, which is pi over 4. This is a right-angled triangle. So yes, we know that for a tangent, we know that the tangent of pi over 4 is equals to opposite over adjacent, and the opposite side of this angle is 1, so it's 1, and the adjacent side of this angle is also 1, so it's equals to 1. So we know that tan of pi over 4 is equals to 1. So tan of pi over 4 is equal to 1. Right over here up above, we have that the arctan function is the inverse of tan function. We know that the tan function takes in an angle and then returns the tangent of this, it returns the tangent of this angle, but the arctan function is the inverse function of tan x. So the arctan function actually returns the angle whose tangent is the given number. So if we want, so we can't find the So we can't find the arctan of pi over 4. That doesn't make any sense because the arctan function doesn't take, or I guess you can find a number, or because the arctan function doesn't take sine an angle, but instead it takes sine a tangent. So we know that arctan of 1, right over here, arctan of 1 is equals to pi over 4. So I know that if tan of pi over 4 is equals to 1, the arctan of pi over 4 is equals to the arctan of 1 is equals to pi over 4. And that's how it works. So yeah, here's our simple solution of the arctan function. It also has some like other properties of the arctan or of the arctan function that you can go over by yourself. Yes, this is a graph of arctan function. Note that the x value of the arctan function is restricted. Or sorry, the y values of arctan function is restricted, which means the angles are restricted in order for it to be a function, or else it's not going to be a function. Okay, so let's say something like, great job, the solution is correct. So now we talked about the arctan function. We're going to move on to our next problem, which is our 7th problem. So this problem is asking us how to find the inverse of sine. So we're asking us to find the inverse of the sine function. Inverse of sine. So first, it's asking us how to find the function inverse of sine function. So the sine function is y equals sine of x, and the inverse of sine function is obviously the arcsine function. For the previous question, we are asking the inverse of tangent function, which is arctangent function. So the inverse of sine function is the arcsine function. Arcsine function equals to, we know that the arcsine function is the inverse of sine function by definition. So this is just the definition of the inverse of sine function, which is arcsine function. And if it's asking us to find the inverse of sine function directly, instead of using the definition, then we need to restrict the domain of the arcsine function, because you can't find the inverse function of the sine function because the sine function isn't invertible, because it's not injective, or it doesn't pass the line test. Yes, it doesn't pass the vertical line test, so it's not invertible. But if we restrict the domain to negative pi over 2 and pi over 2, then we can find the inverse of the sine function, because we're only finding the inverse of the sine function, or we're only taking a portion of the sine function that passes the test and finding the inverse of that part of the sine function. So yes, this is the sine function. We need to say domain, it's negative pi over 2 to pi, or whoopsie, to pi over 2. Function itself not invertible. Sine of x not invertible, so restrict domain. So restrict domain. Yes, so that's the inverse of sine function. Now let's look at an example where we can find the try to find the inverse of a sine function. So let's again use a special triangle. Root 2, 1, 1 is a right angle triangle. And the angle right over here is pi over 4. We know that sine of pi over 4 is opposite over hypotenuse, which is 1 over root 2. This is opposite of the angle pi over 4. This is the hypotenuse of the angle pi over 4, or the hypotenuse of the triangle. So we know the sine of pi over 4 is 1 over root 2. So similarly, we know the sine function takes in an angle, so the arcsine function takes in a side of a triangle. So we know the arcsine function of 1 over root 2 is equals to pi over 4. Okay, so that's our answer right over here for this question, how to find the inverse of a sine function. So first we look at the inverse of the sine function, and then we saw an example of how to find the inverse of the sine function using like an actual triangle or with an actual value. So yes, let's look at the sample solution here. It also kind of explained the arcsine function as we have, and it had another example using a different triangle that we used, but it basically illustrates the same idea. So let's say great job, this solution is correct. Perfect. Okay, we're a minute over time, but this concludes our stream. We're a minute over time, but again, this concludes our stream. Thanks for watching, or thanks for coming, and I'm looking forward to seeing you in our next stream. If you liked our class or our stream, please click subscribe, and this is the live stream of OneClass in the subject area of math. Thanks for watching, and see you next time.